Hello, good morning, good evening. My name is Shubhrata Roy. So today I'm gonna speak about or talk about the idempotency key. Why, from system design aspect, the idempotency key is important, and when you need to actually consider the idempotency keys. But before that, just wanted to give a small introduction about me. My name is Shubhrata Roy. So I'm a lead enterprise architect. At the same time, I've been working with the IT industry for more than 15 years right now in terms of designing, implementing the strategic IT solutions. And I also I'm a thought leader in terms of emerging technologies, the best practices which needs to be implemented for a transformation part. So I have, during my all experience, I have worked in different organizations, from servicing IT servicing industry to IT product to even the IT captive also. So I have worked across various geographies: India, US, UK, Europe, South Africa, Singapore, and Middle East are some of the areas, geographies which I have worked, and also from a industry perspective, it's a banking, insurance, manufacturing. Those are primarily I have worked. Yeah, so this is very short and introduction about me. Now let's come back to the topics which are talking about the idempotency keys. Now think about a scenario uh, where so before that, idempotency key is definitely important aspect when you are making any API call. Now that's for one of the critical things, and which is very critical when you are talking about system design. And system design, when you're talking about with respect to the availability and reliability. These are two key things. Though one of the things that from system design aspect is scalability we talked about, performance we talked about, the security also. But idempotency keys plays a very important role when it comes to the reliability, which is very important, right? So I mean, from a the idempotency key perspective, now think about a scenario where a user makes an API call to the backend systems, and there was some issues with the network. So what could happen? So the network, hence the network, this call which has been made from the user, that request and response. You made the request, and the response is getting failed. So what you can do? Possibly scenarios. These are like first scenario. What you can do, that you can ignore the these things and move forward. Or second thing is, what I can do, that pass the observed errors to the users. A third is important thing is that you can do a retry. I mean, this is one of the typical examples, right? We tend to do retry things. Say something is failed right now, let me do a retry because I want to show that success, or I have that intention to make it happen. But then this failure can happen for any reasons. Now, think about a scenario now. Your users are making API calls. So why it cannot happen, right? What could be the possible scenario that it is failed? So either the server did not receive the request. So in that case, suppose server, if you made a already user made a request to the server and server did not receive. So in that case, if you made a retry, chances of that next time you get a success. So chances of that, if you are looking about some use cases, like for example, if you want to do a payment, is a good example, right? So you try to make a payment, and if it is server, because of server reasons, the server that it is not received, and chances are that if you retry, so it will not deduct from your account anymore. Second scenario is like, for example, network failures. It can happen, right? So a user send the request, API request, and there is a network failure, and then uh, again, the chances are, if it is not happening, the chances you can retry also, and then there are chances of 50, 60% that you retry and you. Third is very important thing. Suppose you already sent the request and you were waiting for the response, and response has been sent, but that when you say the response said that the execution where from server perspective is already happened, right? So that means from your account, whatever the amount is, it is already, it has been told that you deduct, already put it to the other account. So that execution is already done, but it didn't receive to the as a response from user perspective. Now think about this. So this is a very critical way. So these are three, primary reasons that when you are, having that API request and response, and then, server didn't make receive, network failure, server execution done, but it did not receive by the client. So these three lead scenario that where, this request fail can happen. Now, this is how the important thing is that idempotency key is coming into the picture. That's what I said from a reliability aspect. Your system needs to be reliable because whatever things you are executing, your API call, it should not fail. If it is fail, next time you retry, you should know that I mean within that that things are success. So that's why idempotency keys play the key important role from a reliability system design aspect. Now, you know before jumping into the idempotency keys, what is not a typical definition of what is idempotency keys and all. So just to think about the use cases perspective. So as I talked about already that there is payment systems, which is very important. Uh, you raise a payment, then it fails because all three reasons: network, server didn't receive, server execution done, but it did not receive. So in that case, if you are retry again, so it may happen that your account may be deducted two, three, multiple times. This is one of the typical use cases. Then, from an e-commerce perspective, suppose you want to add one items, right, and there is a click two, three times. So, how many times it has been added to your cart? And look at some of the social media pages. There is the likes buttons, so you may continuously likes and it may increase, but it is not happening right in real life. Putting it to Instagram, something it a Facebook page, so you likes it once click and that is done, right? So that's what all three scenarios this system needs to be robust to address those issues. So here the idempotency key is coming into the picture. So now from a nesting perspective, typically you think about the API request, REST API. So there is a four design perspective, right? Either you do the get, either you go to put, delete, and the post. So ideally, what happened? So when you are, raising that, request perspective, get, put, delete. So in generally, these three things are already idempotency in nature. But when it comes to the post, this needs to be actually addressed through idempotency key. So I'll talk about that why these three things are idempotency in nature and why the post is actually not. So let's next move to that. Think about put. You just wanted to update some name, so it is going to database, and suppose today that name needs to be changed from Roy to Subrata. Now this is what will happen if you say multiple requests. First request you do, and second you also retry because of network failure, because server failures, or this or three scenarios which you have considered. But what will happen maximum? It will happen like change it again. The same Roy to Subrata. How many times it will change? Similarly, if you say get information from your database, like any sort of information, you want to know that employee name, employee IDs. So you are actually executing the same things. The more time, times you are sending the request, it will get the same result. There will be no changes in terms of the status, right? And delete is also same. If you want to delete one thing, that it will particular, uh, you know, uh, column, the particular tables, particular things will be deleted. So again and again you try, it will. There is a chances of doing it the multiple times. It is very it is not there. So that is what is said that that get put delete is idempotency nature. Now coming to the post. Now why post is you need to address why idempotency key. So think about like now from a user perspective, right? Client, right? It is sending a request to a server, and it will expect the response, right? So I'm just giving a typical payment example, right? So you are, response sending a request for rupees 10 to be credited, and a payment to happen to other accounts, right? Now, suppose either the server issues, either the network failure, or either the from a server perspective the execution has been done, but while sending the response to the user, there is some again issues, and then because of three reasons that is failed, and you are retry again. See, each time you are retry, so scenario could be like what? Each time it will deduct money from your account. So that's where the the post thing is actually not in advocacy, and that's why you need to address that post scenario, that it is may need to address by the advocacy. So but so I think now you understood that why get, delete, and put are advocacy in nature, and the post is uh, needs to be addressed by advocacy key in terms of use cases perspective. Now coming back to the next, now think about that this request and this you request and you get a response, right? So this request can happen what either it can happen sequentially. Sequentially means what? One request has been sent to the server, and after some pause, some 2 seconds, 3 seconds, there is one more request has been sent. Right? This is all about the sequential. But that may scenario that the request can happen parallelly also, right? So I mean, from idempotency as a key aspect, this will let us in both the things, either the sequential and parallel. So first we consider the sequential part, then we'll discuss about the parallel. So now let's look at the the flow from a sequential perspective, right? And so what has happened? There is a client, there is servers, the request has been sent, and then timeout happened. So to address that, to make that robust, that as I was talking about, the identity key will come. So identity key is actually generally it is what it is. It is a unique ID, right? UID. Now you say, we are talking about the idempotency is unique ID, idempotency is unique ID. But what? After that, what? So I understand that, there's a client, there is a server, it will post, request, timeout will happen. But, what is that? How does idempotency key will approach to the system reliability perspective? So that is where the rules or the agreement comes. I talk to say that it's a rules or agreement, and agreement is between the identity key and the client. So whatever you know, when you are requesting, there should be a identity key would be generated, but it should be from a client perspective. So client should generate the identity key, the first term perspective, and suppose one request has been sent and there is a second more request, right, for different type of operation. So each different type of operation, there will be different identity keys needs to be generated. These are two basic rules from identity key perspective, which needs to be from designing system aspect, which is very important when I talk about the identity. So make sure these things you keep into the mind. So Idempotency key is nothing but a unique ID. Uh, from a request aspect, the key would be generating in terms of from the client, and each operations, if it's a different operation happening, each operation should have one idempotency key. Yeah, so that's the overall approach. Now come to the sequential flow, how the idempotency key is helping, you know. So from a payment or from a card system, that from a reliability aspect, how it can be reliable, so that you retry again, but you should not deduct from your any account any money from your account. So think about the flow perspective. Now this is what the important thing, the flow, how is it going. So you have a a client, and it is first steps, right? You are sending that request. So whenever you're sending the list, it will happen that it will generate that implicit key. So this is the first step, and second step is this key. This key would be in the request header, which will send to the server. Keep this thing in mind. So from a client perspective, as a part of the rules or agreement, it is generating the idempotency key. So whenever you place that client will send the request, the post request, it will generate the idempotency key, and this key will be in the request header, which will send to the server. This is the second step. A third step. Now server will receive that idempotency key. Now what, as a part of the third step, what are the things it will do? It will do a validation. So validation is what? It will check, yes, is there any idempotency key is available? Yes, or there is no scenario, right? It is not available. So the moment it is not, it is a simple straightforward. It will show a 400 errors. So this is the API errors, right? You might looked into the kind of API errors it is there in the various websites. You will see the what 201 error, 400 errors, all these things are listed. So here the validation, it will do validation. If it is idempotency is not, it will straightforward show them. Now, what will happen if validation, it is saying that yes, it is available. So that means first step, the generation of the key, this set is in request header. The third is validation, and it is showing the yes now. The server, what it will do? It will actually read that idempotency key from the DB. Okay. Now, from DB, when it will read, it will see the two things. Either the idempotency key is present. I'll tell you that why it is important again. So it will say that it is present. If it is not present, that is straightforward, right? That is again straightforward. This is as a part of the fifth state, right? Idempotency key is generated. There will be validation. Then server will check the DB, and DB check the will will read the idempotency key from the DB, and it will check whether it is present or not. If not, then it will entry in the DB that okay, so and so idempotency key has been generated. Now please, important thing is the idempotency key also has a life cycle, right? So it is like first time whenever it is generating and coming and validations happening and it is present, so it is entering into the DB and saying the what is the status. Status is like what? Either is acquired. First thing is like it is acquired, or used, or consumed, or claimed. You name it, right? So as a part of the fifth steps, it will if it is present, it will enter into the DB. And sixth step is operation success. That okay, now key is whatever idempotency key is generated, it is consumed or claimed. So there, the the straightforward things are which are happening for up to six. Everything is successful now. Now think about the scenario that whatever idempotency key has been generated from the client, it has a validations, then DB comes and DB is saying that hey, that idempotency key, whatever is generated, it is already present, right? That's where you when you see that in terms of retry things, if you do the multiple retry, it should not deduct your money, right? So 2 seconds, 3 seconds, similar type of request is happening. So that's why it is like even there also it is a two scenarios, right? Key is present, but what will happen here? It will say, okay, now, now key is, it may happen the key is created. Remember the third thing, the key, third, scenario where from a server side the execution did happen, but it is not send the response to the client, right? So it is like what, query is created but not consumed. So that means what, there is a conflict. So in that case what will happen, right? It will show that HTTP 409 conflict status. Okay. Now, if it is again like created and consumed, then it is straightforward again 201 HTTPs. So, I mean, this is the typical workflow from a idempotency key aspect. So each scenario, it is doing that validation. It is showing, it is looking in the database whether the key is acquired, and the key lifecycle also. It is acquired, used, consumed, and claimed. So what I am discussing, it's all talking about the from a sequential. Um, Whenever request is in a sequential. Now think about a scenario. It may happen that okay, um, we talked about the parallel also, right? So it may happen that there is a parallel request is coming, right? So what will happen from the parallel request? Let me just cover it over here. Okay. Now what will happen from parallel request, right? Two parallel things so will come over here, right? So I think all those validations, it will receive the post server validations, will stop a process. But here is a concept. There is a something called from a parallel aspect. There is something called mutual exclusion exclusion algorithm algorithm. So this is important from a when it is there is a parallel request to run. So what will happen that as a part of the mutual exclusion algorithm, then there is a like it is like either it can put a lock on a code level using that synchronized or a mutex. I think from you want to if you want to look into the more about the mutex part of it, you just look into the Google's that will help you. So I think from a it is using that mutual exclusion algorithm. So what will happen here out of these two threads as a part of this mutual exclusion, one thread will reach to the post servers and it will do all this validation, and one thread it will happen that there will be a latency. There will be latency which will make it fail, right? So one thread will reach and second thread will have that go to the post server validations. So overall, I think. This is all about the idempotency key in short, and how it is important from a system aspect, system design aspect when you talk about any system reliability aspect things. And then so I think this is all from the this small video perspective, and definitely I will uh, come up with a next important video. And thank you very much.